So I'm going to start by going through a couple questions from exercise 14b1, which was the questions that we're working through on Friday. I'm going to do question 5, which I hadn't actually set, but it's directly related to the type of work we're doing. So David bought shares in 5 companies on Monday and he sold them on Friday. The details are shown in the table alongside. Write down David's column matrix for the cost price and selling price. So here's our table. He's got 5 different shares that he bought. Now these are the cost price and these are the selling price. So they just want us to write down matrices for each of those. So in this situation, the matrix for the cost price is going to be this column here. So 5A1. Cost price was, now remember when we're doing these matrices we don't have to put the dollar signs in, it's just going to be the values. So it'll be 1.72, 27.85, 0.92, 2.57, 3.56. So the matrix will look like this. 1.72, 27.85, 0.92, 2.53, and 3.56. So that's the matrix for the cost price. And then part 2 wanted the selling price. So since this is the selling price per share, it's just going to be those values in that second column. So part 2, it was selling price, and we've got $1.79, 28.75, $1.33, 2.25, and 3.51. Again, notice I didn't do any dollar signs, I've just got the values in the matrix. Right, then B. What matrix operations needed to find David's profit or loss on each type of share? So this is telling us what price he's bought the share for, and this is the price that he sold it for. So if we wanted to work out the profit or loss on each one of those different types of shares, how could I work it out? For share A, what would I have to do to work out the profit or loss on share A? What was that? 7 cents profit. So how'd you work that out? Yeah, so because that's what he sold it for, you go that value minus that one. So if he sold it for less than he bought it for, it would be a loss. If he sells it for more than what he bought it for, then it's a profit. So can you see, if I take this matrix here, the selling price matrix that we just did, and we subtract the cost price, it will give us the profit for all of the different shares. Can people see that? So if you were to write down, well actually they don't actually want us to even write the profit or loss in B, they just want us to state what we have to do. So you just say we subtract the cost price matrix from the selling price matrix. So I'd go that one there, the selling price, subtract the cost price. And that's what part C asks us to do. Because in part C, it says find David's profit or loss. matrix. So to do that, if I want to know the profit or loss, I take this matrix here and I subtract this one. So I can show that. I might just call this matrix S for selling price. I'll call this one C for cost price. Remember, you can call a matrix whatever letter you want to call it. Doesn't actually matter. So then if we want to know the profit or loss, I'll just call it matrix P is going to be, it's going to be that matrix minus that one. The selling price minus the cost one. So P, the profit or loss, would be equal to the selling price subtract the cost price. And then we can just fill in our matrices. Now remember, to do a subtraction like this, the order of each matrix has to be the same. If the orders aren't the same, can we do a subtraction or addition? No. So you can write out your values for S, which were 1.79, 28.75, 1.33, 2.25, 3.51. And we're subtracting the cost matrix. So cost matrix is at the top 1.72, 27.85, 0.92, 2.53, and 3.56. Now make sure that each of those values lines up properly. So share A lines up with share A, share B lines up with share B, etc. And now it's just a matter of going this value minus that value, that minus that one, and so on to get that profit or loss. So if our subtraction comes out as a negative number, it just means that it's a loss on that share, and if it comes out as a positive, it means it's a profit on that share. So if we have 1.79 subtract 1.72, we're going to get 0.07. So is that a profit or a loss? Good. Then we've got 28.75 minus 27.85. So is that value going to be positive or negative? Positive, and it will come out as 0.9. So again, he made another profit on that one of 90 cents. Next one, $1.33 minus 92 cents, comes out as 0.41. Another profit. Now, 225 subtract 253. Can you see that's going to be negative? Therefore, he's made losses on these ones. So that's minus 0.28. And then E is minus 0.05. Alright, because they were of the same order, that's why we could do that subtraction. So in question 7, our matrices have some unknown values x and y, and they want us to find the values of those unknowns. So basically, since they've told us this matrix is equal to this matrix here, we know that each of the elements in their positions are equal to each other. So I know that x would be equal to y because they're in the same position. I would know that x squared is equal to 4. I would know that 3 is equal to 3. And I would know that negative 1 is equal to y plus 1. Using that information, we'll be able to determine the values of those unknowns. So, like I said, we know that this x, so basically we say equating, corresponding elements. What does that mean? It just means what I was just saying, how this is equal to this, this is equal to this, this is equal to this, this is equal to this. So we know that this x here is equal to what value in the other matrix? Y. So we know that x is equal to y. Now, I also know that x squared is equal to what? 4. So x squared is equal to 4. Now this is useful, because if x squared is equal to 4, how can I work out what my value of x is equal to? You take the square root of both sides. So x will be equal to the square root of 4. So x is equal to 2. Now, when we take the square root of a number, when we take the square root of the number, it can actually be plus or minus 2. Why? Because if I do positive 2 squared, what do I get? 4. And then if I do negative 2 all squared, I also get 4. Alright, so x could be plus or minus 2. That's why I've got the plus or minus. Now, we'll continue to use the other elements in our matrix. So 3 equals to 3. I mean, I don't have to write that. We all know that 3 is equal to 3. But I will write negative 1 is equal to y plus 1. So we know that negative 1 is equal to y plus 1. So this requires a little bit of algebra. I'm hoping that you guys are comfortable with stuff like this. If I want to get this y value all by itself, I need to get rid of this plus 1. So to get rid of this plus 1, if I bring it to the other side of the equation, it becomes a negative 1. So y will be equal to negative 1 minus 1, which is equal to negative 2. So y is equal to negative 2. Are people comfortable with that? Now, this is why it was very important for me to check this one out. Because you know how originally we said that x was equal to plus or minus 2? Now, I've just worked out that y is equal to negative 2. See how we saw that x is equal to y? So does that mean that x could be positive 2? No, x has to be negative 2. So you have to check all of the values in the matrix. So I would say, but x is equal to y, therefore x equals y equals negative 2.